In this tutorial, we're going to perform a conformational analysis of cyclohexane to see what the relevant conformations are that we can find. First thing we need to do is make sure we know which procedure we're using. So we're going to use MM+, a molecular mechanics procedure. Next thing we do is we draw the molecule cyclohexane, model build it to create cyclohexane. Next, we're going to have to vary a number of torsions to generate the conformations. We're going to generate a number of starting points which then get optimized to determine the final conformations. We need to set the torsions that we're going to vary, and so I select this torsion and give it a name. In this case, we're going to give it name Tor1, relatively arbitrary name. And we're going to have one other torsion here that we're going to vary and call that Tor2. These two torsions should be enough to vary to generate all the relevant conformations of cyclohexane. Next thing we do is bring up the conformational search module, and we set various options here. The first thing is we have to define, if we're doing conformational analysis with rings, we have to define those rings. The conformational analysis module needs to know about these rings. So what it asks us to do is select the rings in HyperCam. So we select the ring by double-clicking on the ring, go to the conformational search here, and add that ring, say OK, so that the conformational search module knows about that ring. Next we have to define the torsions that are going to be used to vary, and we'll just take all of these, Tor1 and Tor2, and add them. There are some other options we might use, such as the convergence criteria and so on, but I think we're satisfied to just start this conformational search. And away we go. What happens if we look at this is that various conformational starting points are generated using a Monte Carlo random number generator, and then these conformations are optimized, and the conformational search module collects these conformations. What we see at the moment is three conformations, although really two of them are exactly the same. Some of the times we have to sort of sort these out, looking at their energies and looking at the angles. Really, these are negative values of these angles, and they're really the same conformation, as we can determine when we're finished here. Let this run for a little while, not terribly long, and so we'll assume that we're finished at this point. So the first conformation, this one here, each of these conformations we can look at by putting them back into HyperCam. So we go and we say put molecule, and this is the first conformation, and this low energy one is just the ordinary chair conformation. The second conformation, if we put this into HyperCam and look at it, it is not a chair or a boat conformation. If we look at this, it's actually a twisted, and we call this the twist boat, is one name for this conformation. If we get rid of the hydrogens and take a look at this, it's not really a boat, and it's not really a chair. It's kind of twisted, and we'll call this the twist boat. What we didn't find, and if we go and look at this last one and put it into HyperCam, we'll see that it's really the same conformation. So what we found is two conformations, a chair and a twist boat. We did not find the boat, and the boat is actually not a stable conformation of cyclohexane.